Welcome back to part 2 of lesson 5.4, and we are going to complete example 3. We set it up, but now we need to pull the values off the unit circle. So we have 2 times, let's write these values in, the sine of 315, remember 315 is down here in the 4th quadrant, and the sine value would be a negative, so I've got 2 times negative square root of 2 over 2, times the cosine of 30, which is square root of 3 over 2, minus the sine at 30 is 1/2, positive 1/2, and the cosine at 315 is a positive square root of 2 over 2, positive x value. Now if I multiply that out, I've got 2 times, within here, I still have, that's a negative square root of 6, negative square root of 6 over 4, minus, this would be the square root of 2 over 4. Remember that when you multiply the fractions, you do multiply straight across, but when you add them, you keep the same common denominator, or subtract. So here, I have a common denominator of 4 already, and I'm multiplying by 2. So that 2 will reduce with that common denominator, which will give me a 1/2 in the denominator. So I have negative square root of 6 minus the square root of 2 all over 2 amperes is my answer. All right, let's look at another example. This example, you get to go back to your cute little triangles, but it brings in, and we are going to apply a lot of the different things that we have learned. It may look a little familiar because we've done some of this before, but when you're using the inverses, so it says write as an algebraic expression the sine of the inverse sine of square root of 3 over 2 minus the inverse tangent at x. We're going to treat this as a difference, a difference of a sign, but what we're going to do is we're going to make, let me get a different color here. We're going to make this, if you go back to your formulas like alpha, and we're going to think of that as beta. And then when we draw our triangles, for example, if we have our triangle here for the alpha, we're going to make this alpha, and the sine is square root of 3 over 2. Sine is opposite over hypotenuse. But think about it. If the sine is square root of 3 over 2, and then the cosine would be, it would be 1/2, right? This would be 1. And which makes sense because that would be 4 minus 3, square root of 4 minus 3, which is 1. All right, let's get our other triangle. This triangle, we're going to make the beta angle, and this one says tangent is x. Well, tangent is opposite over adjacent, and so now I need the hypotenuse. The hypotenuse would be 1 squared plus x squared, take the square root of that, right? So square root of 1 plus x squared is that value. So once you have found the triangles and have all 3 sides, you can now expand this and find any of the trig functions that you need. So let's take that value right here. We're going to expand this. So if I have the sine of alpha minus beta, that simply goes, and I'm just going to rewrite the formula. Sine of alpha, cosine of beta, same subtraction, and then I have the sine of beta and the cosine of alpha. Then I'm simply going to go to my triangles and plug in the values. Here we go. Sine of alpha, that's this triangle. The sine, we already know, is the square root of 3 over 2. We have that from the problem. Okay? And cosine of beta. Cosine of beta is adjacent over hypotenuse. So that becomes 1 over the square root of 1 plus x squared. Minus the sine of beta back here. The sine would be x over that square root value, over the hypotenuse, 1 plus x squared. And the cosine of alpha back over here is 1/2. Now I'm simply algebraically cleaning this up. All right, this is going to be the square root of 3 over this denominator of 2 times, right? 2 times that square root. This is, oh look, I already have a common denominator. That's awesome. So I already have 2 times the square root of 1 plus x squared, so I just have my numerators of square root of 3 minus x. Square root of 3 minus x over my denominator of 2 on the square root of 1 plus x squared. Now, as you know, we cannot leave it that way. We need to rationalize the denominator. And all we need to do is to get rid of the square root. So I'm going to multiply by another one of those square roots. Just 1 plus x squared. I don't need to have another 2. 1 plus x squared. When I multiply that in the denominator, then I'm going to have 2 times the 1 plus x squared. In the numerator, I'm going to leave it the way it is. In other words, I'm not going to combine it. I'm going to leave it as the square root of 3. I'm not going to distribute minus x times the square root of 1 plus x squared. All over. Now down here on the bottom, I've got 2 times 1 plus x squared because the square roots were lifted. And I do think I will multiply that out. So I have the square root of 3 minus x. Scoot this up a little bit. There we go. Times the square root of 1 plus x squared, all over 2x squared plus 2. That, I think, I will leave as my final answer. So when you come to class, we will be expanding, playing with these sums and differences of the sine, cosine, and tangent. You may want to start practicing memorizing the formulas and make sure that you can get the sine and the cosine in the right place and the proper signs. I'll see you then.